A ball is thrown horizontally from the roof of a building 56 meters tall and lands 45 meters from the base of the building. What was the ball's initial speed? On this one, really helps to set up the problem just by drawing it. So we've got the ball at the top. It's rolling off with an initial velocity that we don't know. Building's 56 meters tall, and the ball rolls 45 meters to the right. Well, it has a trajectory, as you probably know, makes a parabola like that. So on all of these problems, when you have something flying in the x direction and the y direction, the key is always going to be figuring out time. Because the amount of time that the ball spends falling is the same as the amount of time that it spends going to the right. So if somehow we can figure out what time is, that's going to be really good for whatever we're trying to solve for most of these problems. So on this one, the question that we're looking for is the initial velocity, which is a question having to do with the x direction. So the way that these problems are always going to be set up is you've got y, x, and t. And I always set it up with these three columns. Let me move that a bit. Now the final question that we're looking for is the initial velocity in the x direction. So if your final thing that we're trying to figure out is over on this end, then we'll start on the other end. Because the amount of time that it's spent moving in the y direction is the same as the amount of time that it's spent moving in the x direction. So once we can solve for time, we'll be able to just toss that in for the x, and it should be pretty easy to solve. In this case, to figure out time in the y direction, it fell with a starting y velocity of 0 meters per second, and you know that acceleration equals minus, I'm going to round it off and just call it 10, and you know delta y equals minus 56. So it's really just a matter of tossing in the numbers for figuring out what time is. So delta y equals 1/2 at squared. I'm going to ignore the initial velocity in the y because there was none. It was rolling completely to the right. So you toss the numbers in, you get minus 56. 1/2 of a is minus 5 times t squared. And if you divide and take the square root and all that stuff, you get t equals 1.64 seconds, which is what we were looking for. We wanted to find the amount of time that the ball is in flight so that we can figure out how fast it had to be going to fly 45 meters to the right. All right, so we don't know Vx, but we do know that time equals 1.64. We stole that information from the y direction, so we just toss that in. We know that delta x is equal to velocity in the x times time, because in the x direction, the velocity is held constant. There's nothing pulling the ball left or right. Gravity is always pulling down, so your velocity in the x isn't changing. So we just use the constant velocity formula. Now it's just a matter of throwing in the numbers. So delta x in this case was 45 equals bx times 1.64. And then you just divide those out and you get velocity in the x in order to make it go that far in that much time was 13.4 meters per second, give or take a little bit. See you on the next one.